Good morning, students. Today, in this video, we will see how we can reduce and select important features of data with objective to reduce the computational cost of modeling and in some cases to increase the performance of machine learning algorithms and models. In these connections, topics of discussion are feature engineering, feature extraction, and feature selection. Let us start with what is a feature engineering. Feature engineering is concerned with how we can present data best for a given application or problem. In other words, we can say, actually it turns the input features into features that better represent the underlying problem or applications. These converted features can be used to improve the performance of machine learning algorithms. Further, feature engineering is one of the important tasks in machine learning which creates the huge difference between a good model and a bad model. Next topic, feature extraction. Feature extraction is a process of reducing number of features in a data set by creating a new feature set from the existing ones. This reduced feature set should be able to summarize most information contained in the original set of features. Here you can see feature extraction, like you can take an example, principal component analysis. Takes the original set of features, do some computation and gives the reduced set of features. And this reduced set of features should be able to summarize most of the information contained in the original set of features. Next topic, feature selection. Feature selection is a process of selecting most important features from a given data set. It is desirable to reduce the number of features, both to reduce the computational cost of modeling and in some cases to improve the performance of machine learning algorithms and models. Next topic. In feature selection, the common techniques of feature selections are univariate statistics, next is the model-based selection, and next is the iterative selection. Let us start with the univariate statistics. In univariate feature selection is used to get a better understanding of data, its structure and characteristics. In this, we compute whether there is a statistical significant relationship between each feature and the target. If all features are categorical, we compute chi-square measures between each feature and the target features. However, if all features are continuous, we compute ANOVA F value relationship between each feature and the target feature. There are two common techniques of a univariate feature selection. One is the select k-based method and select percentile method. The select k-based method selects k top significant features of a given data set, and select percentile method select the top significant features of a given data set. Next, model-based feature selection. Model-based feature selection provides importance of each feature. Further, decision tree and decision tree based algorithms are used to provide the importance of features. Next topic, iterative feature selection. There are two common approaches in iterative feature selection. In first approach, it starts with all features and removes features one by one until some stopping criterion is reached. In the next approach, here we start with no features and add features one by one until some stopping criteria is reached. One of the common methods in the iterative feature selection is recursive feature elimination. This method starts with all features, builds a model, and then discards the least significant features according to the model. After that, it again builds a model with all features except the discarded features, and so on, until prescribed number of features are left. Next, the topic is principal component analysis. Principal component analysis is widely used and simple technique for visualization of data set, data compression, and finding representation. Other techniques such as NMF, non-negative matrix factorization, which is commonly used for data abstraction, feature extraction, and other is TSNE, which is commonly used for the visualization of a data set using two-dimensional scatter plot. Let us see. Now I am going to tell you how to select important features from a given data set using Python language. Let us start with this. First, we import the pandas as PD, import numpy as NP. From numpy, import set print options. Okay. Now, import the data, read the data, fruit data, as you are aware of contents of this data. Let us run it. Please wait. Now here you can see the fruit data set contains fruit label, fruit name, fruit subtype, mass, width, height, and color score. Okay. Now we are going to select the features mass, width, height, color, score. Okay. from the data set. Now run it. Here you can see, let us see the 5 instances of the data set. Okay. Now, one of the simple technique to select the most important feature is a Pearson correlation. Actually, Pearson correlation measures the linear correlation between two variables. Okay. Now use the command df.cor.round2. Okay. Now run it. Let us see what happens. Here you can see the correlation between the two variables. Here you can see this is the fruit label related to the mass, width, height and color score. Mass is related with the, you can see the fruit label, weight and the height and color score. Okay. Now here you can see the height is related with the fruit label with value 0.51. Width is related with the fruit label minus 0.33. Actually, it gives the value between -1 to 1, and -1 meaning perfect negative correlation. As one variable increases, the other decreases, and +1 means a perfect positive correlation, and 0 meaning no linear correlation between the two variables. Depending on this relationship, you can select the most significant feature. Here you can see the height is one of the most significant features in this data set. Okay. Now let us take the other technique. Feature extraction with univariate statistical test with the help of the chi-square for classifications. Let us see. Import the select k based method, and this select k based method is used to select the top k features of a given data set. And technique here I have used the chi-square measures. Okay, run it. Let us see. Now here you can see, here I have selected the top 3 important features. Run it. Okay. Okay, here you can see. This select based feature selected the 3 topmost features. Here you can see the value 3.487 into 10 to the power 2, 2.87, and here you can see 1.029 into 10 to the power 1. So what are the top 3 features? Here you can take manually we can determine the top 3 features. You can see first is the first feature, next top feature is the third feature, and next top feature is the second feature. Now let us see your original data set. Here you can see mass is the first feature, first topmost feature, then next is the height, and next is the width. So here we have selected the top 3 most significant features are mass, height and width. Okay. With the help of the select k based. Okay. Now here is this is the coding. You can automatically get the name and the scores of the top 3 features. You can change these 3 features to 2 features or 4 features depending on your requirements. And the coding is, first you score the DF score and convert this fit.score into the data frame. Next, the column, store the columns into a data frames. Okay, and here is use this concatenate these 2 features, fit.score and the x columns with the help of the pd.concate commands. Okay. Now here we can see, you can see the feature score dot columns. First is the feature score, name of the features, next is the score, and here we print the features. Okay, now run it. Here we can automatically we can get the topmost feature is the mass, next top is the height, and next top is the width. You can determine the topmost feature with the help of the select k based command, and manually you can determine, or with the help of these collections of commands, you can automatically, the system will automatically give the top features. Okay, now use the second approach. Second approach is the RFE, import RFE, and here you see we have taken the logistic regression. At this time I will not tell you what is the logistic regression. In the next video I will tell you. Okay, so here we selected the logistic regression model. Okay, here model is the logistic regression, and here again we have selected the top 3 features, but you can change 3 to 2 or 1 or 4 or 5 depending on your requirement, and these are the commands. Okay, REF model, and here we have selected the top 3 features. Okay, next is the RFE.fit command, and now we are displaying the value of this. Here you can see the features value, and next is the feature support and the ranking. Run it. Let us see. Here you can see the selected features. The false indicate means not selected features, true means selected feature. Okay, in the selected features, the value true indicate that specific features are selected. Here you can see we have chosen the 4 features, and in 4 features we have selected the 3 features. Let us see, manually you can determine which features are selected with the help of the selected features, or you can say with the help of the ranking feature. All 1 ranking features are selected, and you can determine manually, you can determine the names of the features. Come back to the original data set. You can say first feature is not selected, second, third and fourth are selected. Let us see what is the name of feature, what are the name of the features. Here you can see first is not selected, means mass is not selected, width, height and color score are selected with the help of the technique, with the RFE technique. Okay. Okay, and you can automatically determine the name of the features with the help of this sequence of the commands. Here you can see name of the feature and score. The features are selected are with the score values 1. Width is selected, height is selected, and color score is selected. Okay. Now here you can see it is not necessary. You can take a logistic regression model, and you can modify the logistic in the place of logistic regression. You can take the random forest classifier techniques, or you can take the other models for the RFE technique. You can change it and do the experiment. Now, next is the model-based feature selection. Here you can see we have imported the extra tree classifier and the random forest classifier. Okay. Here again you can use the extra tree classifier, yeah, or you can say the random forest classifier. So here we have used the random forest classifier. Okay. Now import these methods. Okay, here you can see the score values are 0.159, 0.235, 0.23 and 0.375. And again you can manually determine the significant features. Here you can see color score value is 0.37, width is this, height is this. Okay, here you can see the top significant features are color score, width, and the height. Okay. Now instead of this extra tree classifier model, you may choose the random forest color classifier, or you can choose the other tree based algorithms for the model based feature selections. Okay. Now here you can see here we have chosen the random forest classifier. Run it. Same three values are selected. Okay. Same two. Here we have selected the two features only. Now let's do the principal component analysis. The principal component PCA is selected, and it here you can see all four features have converted into the three principal components. Here you can see the three principal components, and the explained variance are these: 9.99 into 10 to the power minus 1, 3.96 into 10 to the power minus 4, 4.277 into 10 to the power minus 5. In the place of 3, you may change it. Here you can see 2 and done it. Now it is two principal components are shown in the front of the screen. So depending on your requirement, you can select the two principal component or three principal component or four principal components depending on your data or depending on the requirements. Okay. Now you can see. So we have seen how to select the relevant features from a given data set with the help of the Python language, and we have also seen how to reduce the features with the help of the principal component analysis, PCA. These are the references. Any questions? Thank you very much.